Hey everyone, I'm Sam Wilt. I am a machine learning engineer at Plainsight, and I'm here with Charlene to do a demo today.
Hey everyone, my name is Sean. I'm a software engineer too at Plainsight. And before we hop in and Sam gives us a more in-depth explanation of what we're going to talk about, I just wanted to talk a little bit about what Plainsight is and what we do as a company. So Plainsight is a computer vision platform that helps teams build, test, and deploy CV models end to end without getting stuck on data collection, labeling, or fragile infrastructure. At a high level, we let engineers go from the ideation stage through the model validation and the deployment in one workflow. And the reason we do what we do is because most CV teams get blocked by slow data pipelines, and Plainsight focuses on speed, correctness, and iteration before production.
So today our demo is going to be discussing how we have implemented an MCP server to interoperate with our platform, and the integrations can help you construct pipelines and do some of the operations that would normally be need to be done through a portal. One of our motivations for this was that often people need to leave their IDE and go into different web experiences, and MCP offered a way to allow the user to bring their own agent. We integrate with any off-the-shelf commercial coding agent solution in order to allow you to interface with LLMs instead of always handling everything manually through the GUI, and interface with ideally any IDE that you might want to use as well.
Yeah, sounds good. And once we had fast iteration and confidence at the data level, we were able to integrate this MCP tool and its 12 subtools into any IDE. The next bottleneck, obviously, after this MCP server got deployed, was deployment itself. Before this, deployment changes were honestly pretty painful. You'd run a pipeline, wait for infrastructure to spin up, manually track state, and hope nothing broke along the way. And debugging in this case meant digging through logs and trying to reconstruct what even happened. So we focused on automating deployments end to end. And now every pipeline run has a clear lifecycle from creation to running to completion. And that state is what is tracked automatically. There's no guessing, no manual cleanup, no database hacks to figure out what went wrong. Architecturally, this is what let builders move with confidence, and you can now push changes, redeploy, roll forward or back, and always know exactly where things stand. Big win here isn't just reliability, it's mental overhead. Builders can stop thinking about how to deploy and can focus on what they're building.
Okay, I'm going to jump into our away from slides. I can just transition to our demo here. Okay, so basically what we have here is some of those operations that we talked about with the MCP server being able to actually hook into the platform in order to handle some of the lifecycle for you. Um, I have just a few basic operations that I'm going to have it do. The system has tools in order to operate on all of the entities in here in order to carry out these steps. Um, I'm going to have it, do the steps. You can read them if you like. And the idea is that you wouldn't necessarily have to because the system now has the ability to call all of those endpoints, and the agent is implemented on the server side, giving it status information on all of these various entities involved in these steps. You don't necessarily need to have database access or anything in order to understand what's going on with the system, and neither does your agent. It can actually just use the system as intended. I'm probably going to get a couple of prompts to authorize various tool uses here, but let's see if it, yes, this is a good step. What are your steps? Yeah, you could see why the agent would get confused. One of the changes we have in the pipeline is an update to the MCP server to make these path interpolation errors return something a little bit more reasonable on the client side, as opposed to surfacing the error directly from the API that results from the MCP server doing the mapping into what the API entities actually are. Okay. It's JQing the open API specs so that it can understand what the MCP tools are doing on the API side and what their required arguments are. Again, because the diagnostics right now don't give it a great insight into what path parameters or payload parameters it might be missing. Huh. Okay. I think it's correctly identifying that there are no tests associated with the project that it chose for integration testing. All right, I should probably have been more explicit. Right now, the MCP server doesn't support cross-tenant operations. Right. Oh, good. It's using the correct file. What? File not found. Huh? Oh, it's running under Docker. This is gonna take a little while.
I think this is an ode to how well the MCP server is doing at diagnosing its own issues, which could very well happen when the user tries to use it to create things. And so, what is a positive here, even though some of the steps are airing out temporarily, is that the server itself is able to self-diagnose, self-fix, self-search, and take away a lot of that manual error coding from the user. So
Okay. Oh, yeah. We're deviating from the program just a little bit because I'm having it pull for the synthetic video creation job, and we're creating a synthetic video server side instead of uploading the one that we were planning on. Oh, uh, I suppose that's it. We added a synthetic video to our corpus. We were able to automatically create a test, create an assertion associated with the test with respect to what we expect to be in the foreground of this video. And then, it was running under Docker, so I couldn't tell the MCP server where the video file was because it wasn't mounted under the file system for the container. So instead, we generated a synthetic video, and we were able to pull the status and successfully list that video is associated with our project in the video corpus. So all of that is good. Obviously, there are still many improvements to come, and we're hoping to continue to iron out the experience.
Yeah, and really quickly for what we demonstrated there, we had the project, the filter pipeline created, the tests created, the assertions created, and we were able to generate the synthetic video. And yeah, when you put all this together, synthetic data, validation, and automated deployment, you get something pretty powerful. The core takeaway from all this was that builders can now go from zero data to a validated pipeline using the MCP server without waiting on customers. They can generate data, test assumptions, validate correctness, and deploy all before anything ever hits production. And that change shows how quickly teams can move and how quickly they can ship. Instead of finding out if something is broken weeks later from real world data, you find out immediately during the development. And that feedback loop is what actually enables fast and pretty high quality iteration. So the end result isn't just a pipeline or the MCP server, it's workflow that lets builders move faster, catch issues earlier, and build with a lot more confidence. And yeah, that's it. Thank you all for watching and listening. And hopefully the MCP server demo shows not only how well it can do the tasks that it has been asked, but how well it can self-diagnose its own issues.